Hello everyone, and welcome to the course of Research Methodology in Natural Sciences. I am Udiptya from IIT Madras, and this is the week 7th discussion of this. So, last time we couldn't do it on Tuesday, but then I postponed it and now doing it. In this part, what we will look is it's basically on continuation on elements of scientific measurement. So what we first we went through some basic tools like normal distribution, central limit theorem, and also did some questions, basically practice questions on that. And now we will be extending and continuing the same lines. We will be learning on something on proportions. So we also have some questions on that. Then box and whisker plot, a type of data representation, propagation of errors, and some issues in hypothesis testing. So that I think is more covered in a theoretical way. So I don't have much questions on it, but then most of the questions will be on this three parts. Coming on measurements of proportions, this probability distribution can be broadly uh, classified into two ways, that is on discrete probability distributions, and then you have continuous probability distributions. Okay, so here we have some familiar names like binomial distribution, Poisson distribution. You might have known about geometric distribution. Similarly, here you have something called as normal distribution, chi-square distribution, and some others. The main factor here is to know what is discrete and what is continuous distributions. So in discrete random variables, it means that it represents countable data, such as the number of defective items in a sample. A discrete random variable assumes each of its value with certain probability. And then you have continuous random variables, in which it represents the measure of data at all possible values, for example weights, heights, temperature, distance, etc. So that's the difference. In discrete, it's the countable data in terms of how many is like how many defective items are in the sample, whereas in continuous, it's like in a class there will be different weights of people, different heights of people, so it's a continuous data. So there you have continuous random variables. So some examples. The basic one is Bernoulli distribution, in which we consider 1 as a success with probability p, and 0 is as a failure with probability 1 minus p, because it's the like we have only two because we have only two outcomes, success or failure. So 1 minus p, there is no other in between cases. Okay. And then extending this Bernoulli, there is binomial distribution, in which we calculate the number of successes, basically the number of 1, yeah, because 1 means success in when you have n trials, like n independent experiments, how much time you get success. So it's and you have independent of Bernoulli trial, so each trials will be independent. Okay, you will do the experiment independently and then carry out the distribution, so it's binomial distribution. Okay. So that was two discrete distributions we saw. Okay, coming to the box whisker plot, I think this you have gone through it, but all in all, these plots illustrate the first, second, and third quartiles, as well as the minimum and maximum values of the data collected. So the kind of range and first, second, and third quartiles. The second quartile is that is called as Q2. It's the median of the data, and the first quartile Q1 is the median value of the samples that fall below the Q2. Okay, and the third is a similar way. It is the median value of the samples that fall above the Q2. So yeah, here we see Q3, Q1, Q2 is the median, Q3 is the median value of the samples that is falling above the Q2, and then Q1 is similarly that fall below the Q2. Yeah, so it's the median value of this data points. So the box and whisker plots are useful in that they highlight whether there is a skew to the data or any unusual outliers in the sample. Okay. Skew in a means is that it is whether how the data is spread across, yeah, whether it is biased to one side of the data or not. That's the skewness. Or any unusual outliers means some data that is not expected, or some way it's not matching to the whole data set. Yeah, the width of the box distance between q1 and q3. Okay, this is called as the interquartile range. So in this measure, the extreme values have no effect. Okay, that you might have seen when you calculate it. So in the interquartile range is essentially third quartile versus first quartile, that is there. Then something there is so this kind of extra information, but it's on you, but I am just telling you. There is something called as quartile deviation. It defines the half the difference between the upper and the lower quartile. So this is the formula. Okay. It's it's the semi interquartile range, and the coefficient of quartile deviation. And then Q1, Q2, Q3 denote first, second, and third quartile respectively for symmetrical distributions. Okay, if the distribution is symmetrical, the median can be calculated by this. Okay, this formula is. Okay. Then if somebody asks about percentile range, it's basically the 90% to 10% data that is there. This measure takes into account the values between which is the central activity. So basically 80% of the data, wherever it is the percentile range. So sometimes they can in place of interquartile they can ask maybe what is percentile range. So that's what I wanted to highlight here. Then there are some there are some topics on error propagation. So it's basically when you calculate here we are calculating the sum of two variables, and then what's the overall error coming. So this can be calculated by this one, and in cases of addition it's this formula, in cases of multiplication division it's this one. So I won't go to the derivation. I think in the class the derivation has been done, and then there is some general formula which all this can also be derived from this one. Okay, so this is the master formula, and you get all this from that one. Okay. So going to the problems, this is the first problem. Suppose that 15% of the 1750 students at a school have experienced extreme levels of stress during the first month. Our newspaper doesn't know this figure, but they are curious what it is, so they decide to ask a simple random sample of 160 students if they have experienced extreme levels of stress during the past month. Subsequently, they found that 10% of the sample replied yes to the question. Assuming the true proportion is 15%, what is the approximate probability that more than 10% of the sample would report that they experienced extreme levels of stress during the past month? Okay, so we're looking into this question. I'll give around 5 minutes to think and solve or kind of discuss about this. Later I'll try to discuss with you all how that can be done. Any answers? Okay, then we will solve the question. So it is written that okay. So it is written that we have to assume that 15% is a true proportion. So basically, you can take nu as 0.15 or 15% of the fact. Okay, because in 100 students, you can say that approximately 15 of them are stressed. Okay, now they told to find that 10% of the sample replied yes to the question. So we have to check about for 10. Yeah, so 10 by 100, it's 0.1. Yeah. So for uh, calculation of sigma for proportions, this formula you might have seen here. P1 minus P by N. Yeah. Okay. So what will we do is we will put the value here. So P means 0.15. 1 minus P is 1 minus 0.15 divided by, we are doing 160 students here. Okay. So if we calculate it, this is coming around 0.028. Okay. So now the question is, Now the question is, we have a standard normal distribution curve with nu equal to 0.15, and somewhere here we have x, which essentially is 0.1. okay, so we have to find the area of this under this curve. So now what we have is, we have to get the z value here, again z value here, and you have to add it with 0.5. so because this area is essentially, you know that this is 0.5, so you have to find the area of this shaded portion and then add it with 0.5. Or maybe you can also do the other way, you just minus this portion, yeah, this portion from 1, that also does the job. So first is, you have to find the z value. You have the sigma z, you can find using this formula, z equal to x minus nu, yeah, by sigma. So you have all the values to find out the z, and from the table you'll be able to find it. Is it understandable for everyone? You guys are understanding it? Should I explain it again? Everyone understood? Should we go ahead with the next question? Okay, basically we have to calculate the z here. So the z, what z comes out to be? So calculating z, if you put all the value, x equal to 0.1 and nu equal to 0.15 and sigma equal to 0.028, z will be 1.78, yeah. And if you calculate this value, this value, yeah, it is equal to 0.0373. Okay, now the answer will be 1 minus, because the whole area under the normal distribution is 1, to minus only this. Okay, so it will be 0.9624 or 96%. So the answer will be 96%. Okay, so assuming, what is the probability that more than 10% of the sample would report that they experienced extreme levels of stress during the past month will be 96%. Okay.
Hello.
Yeah, please.
Sir, actually x is zero point 0.1 and the mu is 0.15, so it should be negative value, no sir?
Yeah, but anyway, Z is modulus, so
Okay, sir. Okay.
anyway, Z will be negative. This will be negative actually. Yeah, but
Okay. From 1.78 we have to take from Z table, sir.
yeah. But anyway, positive or negative, the Z value will only be. It's a
Okay,
modulus,
sir.
so you have to take it.
Okay.
Should we go ahead? Okay. So problem 2 is, suppose there are two strains in a species of bacteria, one benign and the other virulent. You have read a paper that says that more than 30% of the bacteria are virulent. You have repeated the experiment and cultured the bacteria, then you pick up a bit of the culture and find 200 bacteria in it. On a closer inspection, you find that 72 of them are of the virulent strain. Does your observation support the report in the paper with 95% level of confidence? What was the value of Z?
Sir, will they provide a Z table in the exam, sir?
Yeah, or the Z values will be given at least in the
Okay.
questions. Yeah,
Okay,
but
sir.
for now, I wanted you all to search it, but I think it's okay.
Okay, sir.
Okay, then we will solve the question. Anybody solved it? So first we can define two hypothesis. First is null hypothesis, in which the probability is less than or equal to 0.3 or 30%, or alternate hypothesis is HA is greater than 0.3. So what all we know is nu is equal to 0.3, yeah, and x we have 72, 200, and it's 0.36. Okay, and what we can calculate is sigma. Yeah, sigma, same formula, p1 minus p2. Yeah. So it will be 0.3, 1 minus 0.3, divided by 200. Okay. So, okay, then you got the answer. Yeah. So z will be x minus nu. X is 0.36 minus 0.3 divided by 0.032. So z will be 1.851, just like somebody replied. Yeah. So the question now is, should we reject the null hypothesis or not? What's the answer on that? So this is the z value you got from the z test. Yeah. So what is the value of z value at 95% confidence?
1.96, sir.
1.6.
1.96. Is it 1.96?
Yes, sir.
Okay. So we have 1.851. Yeah.
So it is support, no?
So z is 1.851, which is lower than 1.96. So what does it mean?
So it supports the report.
So can we reject the null hypothesis?
No need to reject.
Okay. So we can't. So if it had been higher, then we have to. So we can't reject the null hypothesis. Yeah.
Sir, one more doubt, sir, actually. Sir, here x value you have taken 72 by 200. Previous problem you have not taken like that. You have taken 10% instead of 160
Because
by
it was
1000.
directly reported. Yeah, that's why.
Oh, okay.
Just reported directly. That's why.
Okay, sir, sure. Thank you.
So we can't reject the null hypothesis. Yeah. So null hypothesis can't be rejected. Understood? Yeah. Okay. So we go to the next one then. So a random sample of n equal to 50 insurance records of physicians selected from the file of an insurance company shows that 10% of physicians have been involved in one or more lawsuits. Estimate the population of all physicians covered by the insurance company who have been involved in lawsuits using 95% confidence interval. So if there is any doubts in the questions, then you can ask, because this is kind of a tricky one. Tricky in a sense, it's not, you have to think some other way. It's the same formula that is involved, but in some way it asks for something else. So yeah, not the ones that you have solved before.
Sir, what is the formula for this, sir?
The formula remains the same actually. That z equal to x minus nu and sigma. Because the game is that, but you have to find the range. Okay, here. So I want you guys to try. Then anyway, we will try to solve it. So try to write down whatever information is there. That I think will help. Okay, then we will try to solve it. Okay. So, yeah, a random sum equal to 50, 10%, 95%. Okay, so basically we have to find so we have a normal distribution curve. So the thing is, we have to find how much is this population. Understood? So there will be two Z1 and Z2. We have to find this Z1 and Z2 and basically find what area this one is lying. Okay. Or okay, so let's find the sigma first, yeah, because we have most of the values. P1 minus P by n. So P here is 0.1, yeah, 0.1 minus, there will be 1 minus 0.1 is 1.9 divided by 50, yeah. So how much it comes? Okay, you can leave it like that way. 1.96. So the here if we calculate z is x minus nu divided by sigma, yeah. Place of sigma we put this will be plus minus 1.96 x minus 0.1 divided by root of 0.1 into 0.9 divided by 50. So now we will have two values of x, yeah. So one will be x equal to 0.1 plus minus 1.96 root of 0.1 into 0.9 into 50, and another one will be 0.1, so it will be positive 1, and another one will be negative 1. So yeah, if we have to calculate the value of this root essentially, so I think this value will turn out to be 0.0134. Okay. So this will be the answer. So it basically tells the range between which the physicians will lie. Yeah. Okay. So we'll go ahead then. Yeah. If any doubts, you can ask. The pulse rate of eight contestants in a 100-meter race, checked immediately after the race, where this. You have to determine the range, the 25th percentile, the 75th percentile, and the interquartile range. Okay. Any answers? No answers? So the first step to solve this question will be to arrange this data in like in a ascending order here, to start from the 78 here. That's the, then we have 85, then we have 89, then we have 96, then we have 98, 99, and 02, 07. So that's the arranged order. So this is the arranged order. So the first question is the range. So the range is equal to the first data, this one, yeah. So the range is 107 minus 78, 97. Now coming to the second one, 25th percentile. Okay, the 25th percentile is also known as the Q1, and 75 is also told as Q3.
Sir, range is 97 or 29, sir? How much?
Huh?
107 minus 78, no,
Oh,
sir?
sorry. Yeah.
Okay.
It's what? It's 29. Sorry. Okay. Sorry. Thanks for. So the Q2 will be what will be the Q2? I'm first calculating the Q2 actually.
97.
Median.
97.
How?
Middle number both 96 plus 98 divided by 2.
Okay. 96 plus 98 divided by 2. It's coming as 97.
Mm.
Okay. Then Q1 is, what will be the Q1?
थोड़ा से डाउट है सर.
So we'll add 85 and 89. Okay. 85 plus 89. This will be 87. Okay, so Q1 is 87. Q3 we will add 99 and 102. This will be 100.5. Okay. Then coming to interquartile range, it will be Q3 minus Q1, which is 100.5 minus 87, 13.5. Yeah, 13.5. Okay. So this is the answer. Okay. Any doubts?
Sir, if the number is changed, matlab if in case 11 number, how we can go for the Q1, Q2?
Then it's the so there we told, yeah, the Q1 is basically the median of the first half, and then you are when you are calculating the median, if the median basically has two formulas, yeah, for odd and even numbers. So you will similarly you will only consider those numbers, the first half, and then you will find the median, and then that will be the Q1, like how you did here. There was a issue, yeah, there is 96, 98, then consider this number and this number. Similarly, like that you will consider it.
Sure. Thanks.
So what about 25 percentile they are asking? So 75 percentile, 25 percentile. That is Q1, Q2 they are asking like that, sir?
Yeah.
Okay.
It can, like, that's why I didn't ask you Q1, Q3. I wanted to give it in that way so that you all are familiar with them.
Okay, sir.
You have conducted an experiment to measure two values, X and Y, and have obtained the following data. X values, this is this, standard deviation 0.34, number of data points 25. Y values, this is this. So calculate the extremities of the error bars in X and Y. Calculate the estimated values of quantities X plus Y, XY, and log ln X, including the error bars. Define a range of X in which true value of X must lie with 99% probability. So this is a question of error propagation.
So formula for this?
Error propagation, the formulas were this one.
Okay.
first one, how you are doing? First part. So, as we had seen, yeah, mostly the values, yeah. Here we see the standard deviation given and the number of data points given. So we can always calculate the standard error, yeah. So standard error formula. Nobody remembers? its standard deviation divided by number of observations. Yeah, so in case of x, it will be, in case of x, standard error will be 0.34 divided by root 25, that is 5. Yeah, and in case of y, it will be standard error equal to 4, no sorry, 0.3, point 0.27 divided by 6. Can anybody calculate and tell? I do not have a calculator. 0.34 divided by 5 is 0.068, and this will be 0.045. Okay, so the first option, first answer will be this one only, like 5.6 plus minus 0.068 for x, and for y it will be 4.9 plus minus 0.045. So calculate the values, estimated values of the quantities x plus y, xy, and ln x. So this you have to put it in the formula. Okay, so first you have to find x plus y. So x plus y is 5x plus y, it is 5.6 plus 4.9, so it comes around 10.5. Yeah, and then you have to add the error, the collective error. Yeah, so that how you have to calculate is you have to take the root of it. Okay, so the root here will be what was the root? 0.068 whole square plus 0.045 whole square. So whatever will come, that plus minus this. Okay. For xy it is similar, and xy you have to find as you have to first calculate the multiplication product. It is 5.6 into 4.9, it is 27.444, and from the formula you can see that standard error of xy is equal to 27.44 multiplied by 0.068 divided by 5.6, okay, whole square plus 0.045 divided by 4.9 whole square. So this whole will be under root. So whatever the value comes, you have to add it here. Okay. So this will be for xy. I think for ln x, I think you would be able to calculate it. Is it understandable, everyone? Okay, everyone understands it, yeah?
Yes, sir.
Okay, good. Okay. This one, ln x part and the options, the question C, you can continue solving it. That I won't discuss in this question, in this session. Suppose you are performing an experiment to measure the DC resistance of cesium bismuth bromide. You have taken 25 readings. The values in mega ohm are this. You have to draw a box whisker plot. Identify if there is any outlier. If you have to report the measured value in a scientific journal, how would you represent it? With what level of confidence can you state that the actual value must be below 7.5 ohm? Okay. Anyone done? So the first step will be to arrange this in ascending order. Yeah. So I hope you all have done it. What is the Q different quartiles? Q2, Q1, Q3. Q1. Huh?
Hey, par.
Q1, what's the value? Okay, if you guys want, you can actually solve it at home. Yeah, because this sentence is very
Sir, Q2 is 4.9.
okay. 4.9.
Q1 4.
Huh?
Q1 how to calculate, sir? 4 आएगा क्या?
I have not calculated it. That's why I don't know. How much it is coming?
Sir, actually, this is the 13th digit, है ना? In between, how we can take which number? थोड़ा सा.
Then you take the mean of it. Two numbers coming.
Sir, total 25. 13 is the 4.9. That means 12 may in between we need to take.
Yeah.
That means 4 आएगा, sir.
Others didn't do. Only one person did. Only one person did. So you have how many numbers? 25. Yeah. And okay, 12 number will be there. Others didn't try. So you have to take if it is even number, yeah. You have to take the
Q3 is 7 sir.
No,
Q3.
I was thinking if there is even numbers, then you have to take the sum of two numbers
by 2.
Yeah, by 2. So it will be I think 4.1 plus 4.2 divided by 2. And similarly it will be because 4.9 is 2 times, yeah. Okay, 4.9 is 2 times, so another one will be what is the thing? Then it will be how many numbers in the second Q3?
6.9, 7.19.
So what will be the answer? So for Q1, what you are saying is 4.15, yeah?
Yes, sir.
And Q3?
7 is, sir.
7. Okay, cool. So any outliers? So you have to check Q1. If anything is there in Q1 minus 1.5 IQR and Q3 plus 1.5 into IQR. Okay, better is you all solve it actually, because this question is solvable, not that much hard. Yeah, I'll keep it this way. You will solve it, then we can discuss this as the first thing in the next session on Tuesday. Because then it gets because these questions are easy, won't need much explanations. Okay, is it okay for everyone? Is it okay?
Okay, sir. Thank you.